According to the National Electrical Code, specifically Article 310.5, the minimum conductor size for circuits rated over 2000 volts is 14 AWG. Article 300.15 states that electrical conductors installed in a raceway or enclosure must be insulated for the highest voltage that may be present in the raceway or enclosure. Based on these National Electrical Code requirements, it is not permissible to install 18 AWG thermostat wire in the same junction box as 12 AWG supply conductors for a furnace. This is because the thermostat wire is likely not rated for the same voltage as the supply conductors. The fact that the other control wires in the junction box are also rated for 120 volts does not change this requirement. All conductors in the junction box must be insulated for the highest voltage that may be present. Installing conductors with inadequate insulation can create a safety hazard. In the event of a short circuit or ground fault, the insulation on the smaller wire could fail, causing an electric shock or fire. To ensure compliance with National Electrical Code requirements, use 14 AWG or larger thermostat wire in the junction box. The wire should be rated for at least 120 volts. Alternatively, one could install the thermostat in a separate enclosure with its own dedicated supply. The National Electrical Code is a comprehensive set of standards that governs electrical installations in the United States. It's updated every 3 years to reflect changes in technology and best practices. It's crucial for electricians and anyone working with electrical systems to be familiar with the National Electrical Code to ensure safety and compliance. When choosing conductors, firstly, the ampacity of the conductor must be sufficient for the load it will carry. Secondly, the insulation rating must be appropriate for the voltage present in the enclosure. Thirdly, the conductor size must meet the minimum requirements specified in the National Electrical Code. Using undersized conductors can lead to overheating, voltage drop, and potentially fire hazards. Always consult the National Electrical Code and a qualified electrician when working with electrical systems. Ignoring these regulations can have serious consequences. One should always prioritize safety when working with electricity. Before beginning any electrical work, disconnect the power supply. Use appropriate personal protective equipment, such as gloves and safety glasses. Double-check all connections to ensure they are secure. If unsure about any aspect of the work, consult a qualified electrician. Regular inspections of electrical systems can help identify potential problems before they become serious hazards. Look for signs of damage, such as frayed wires, cracked insulation, or loose connections. Address any issues promptly to prevent electrical shocks or fires. The National Electrical Code provides detailed guidance on how to properly install and maintain electrical systems. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. Following the National Electrical Code can help ensure that electrical systems are safe and reliable. Understanding the basics of electrical theory is essential for anyone working with electricity. This includes understanding concepts such as voltage, current, resistance, and power. A solid understanding of these concepts can help troubleshoot electrical problems and prevent accidents. Proper grounding is crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, which can help prevent electric shocks. Ensure that all electrical equipment is properly grounded according to the National Electrical Code. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices automatically interrupt the flow of current when it exceeds a safe level. Ensure that overcurrent protection devices are properly sized for the circuits they protect. Electrical boxes provide a safe enclosure for electrical connections. They protect the connections from damage and prevent accidental contact with live wires. Ensure that all electrical connections are made inside approved electrical boxes. Wiring methods refer to the way in which electrical conductors are installed. The National Electrical Code specifies different wiring methods for different applications. Choose the appropriate wiring method for the specific installation. Electrical panels are the main distribution point for electricity in a building. They contain circuit breakers that protect individual circuits. Ensure that the electrical panels are properly labeled and that all circuit breakers are in good working order. Regular maintenance of electrical systems can help extend their lifespan and prevent problems. This includes cleaning electrical panels, tightening connections, and replacing worn or damaged components. When working with electrical systems, it's important to use the right tools. This includes insulated screwdrivers, wire strippers, and multimeters. Using the wrong tools can damage electrical components and increase the risk of electric shock. Always follow the manufacturer's instructions when installing or maintaining electrical equipment. Incorrect installation can void warranties and create safety hazards. If you are not comfortable working with electrical systems, hire a qualified electrician. Electricians have the training and experience to safely and properly install and maintain electrical systems. The National Electrical Code is not law, but it is widely adopted by state and local governments. Compliance with the National Electrical Code is often required by building codes and insurance companies. Staying up to date with the latest edition of the National Electrical Code is essential for anyone working with electrical systems. The National Electrical Code is available for purchase from the National Fire Protection Association. Many online resources provide information about the National Electrical Code. However, it's important to verify the accuracy of the information before relying on it. Attending continuing education courses on the National Electrical Code can help stay current with the latest changes. These courses are often offered by trade schools, community colleges, and professional organizations. Consider pursuing electrical certifications to demonstrate your knowledge and skills. Certifications can enhance career prospects and increase earning potential. Joining professional organizations for electricians can provide networking opportunities and access to valuable resources. These organizations often offer training programs and advocacy for the electrical industry. The National Electrical Code is a living document that is constantly evolving to reflect changes in technology and best practices. Input from electricians, engineers, and other stakeholders help shape the National Electrical Code. The National Electrical Code is a consensus standard, meaning that it is developed through a collaborative process involving a wide range of stakeholders. This helps ensure that the National Electrical Code is practical, effective, and safe. Understanding the history of the National Electrical Code can provide valuable context for its current provisions. The National Electrical Code has evolved significantly over the years to address new challenges and improve electrical safety. The National Electrical Code is an essential tool for ensuring the safe and reliable use of electricity. By following the National Electrical Code, one can minimize the risk of electrical shocks, fires, and other hazards.